Right, here in part 3 of our series on strings, we're going to actually write a few programs using a few of the things that we've learned already, learning how to apply them. Let's just go back and recap here. I have this main.c program set up, and I want to remind you then that C strings are treated as arrays of characters that are terminated with a null terminator character, right? That's what makes a string different than any other array, is the fact that we have this null terminator in there. Right, and we've seen now that C provides alternative ways of declaring and initializing a string. Right, we could do it in this way with creating an array. Let's say I'm going to have 10 here. We could then actually use an initializer list, and then character by character, right, type something in like, oh, let's type in ELEC for electrical engineering. All right, so if I'm going to do all caps, I would do this, single quotes around the single character, the initializer list. Right? And now what this will do is if we were to go into memory and take a look at this, we should be able to see it storing these characters in these array positions, right? And null terminating it. Let's just go ahead then and say, well, we could print this information out. So if we use %s, right, and we give it the name str, the name of our array, we should be able to print that information out. I want to do something with it so the compiler doesn't optimize it out of memory. Right, so I built it. Let's run it. And sorry, I've not added this to the project. This is an old example. Let me just kill this. So I wanted... so I was running the last executable. Let me add this file to the project. Yes, here it is. Let me just clean out my workspace. Let's rebuild. All right, so now run the cursor. All right, so we've run the code right before the printf. You can see here in our array str, we store the characters ELEC, and here's the first null terminator there. Right, it looks like it initialized the rest of it with null terminated characters, simply because we use this initializer list here. Remember, everything that, anytime you use an initializer list with an array, when you don't initialize all the elements, it sets the other elements to 0. Because these are character arrays, we see this \0, right, for the null terminator, which is still the decimal value or the binary value of 0. All right, so I wanted you to be able to see that in memory and see the fact that even though we don't have a null terminator in this list, C goes ahead and puts a null terminator to indicate the end of our string. Right, if we said next line, well, we'd see then it prints out all of the characters. So when it prints out all of the characters until it reaches the null terminator. That's what printf does for us. Right? So that's one way that we can initialize this array. We've also seen then an easier way to do this, because here we have to spell out everything in the list. We could have just said char str 10, but we could now use this idea of this string of characters and do this. So let me comment out this one. We can't have two things with the same name. And let's rebuild run to cursor. Now you can see then in memory, right, str has the same thing in its memory. ELEC with the null terminator, right? If we execute the next line, it still prints it out in the same way. So two different ways then we see that we can actually then declare and initialize, right? Here we did it with an initializer list. So when we use an initializer list, since these are char data types, we had to then show each character as an individual character, single quotes. Remember, this gives you a character constant. Double quotes, this gives you a string or a constant char star. So the data type of this with a single quote here is char. This is const char star. Right. Differences in the data types. Takes a while working with these to get used to that. Right. We have our two different ways then. And then of course we've seen how to use the %s, right, to work with the string to print it out. Now, what we could do is let's take an example then and work with a pointer, right, to point things out or print things out. So what we're going to do is let's stick then with another example here. Right. And what we're going to do, instead of using printf and the %s, we're going to go ahead and then let's create then a pointer. So char star p, so pointer to string ptstr, right? And let's then go ahead, that declares it. Let's go ahead and initialize it to point to str. What we're going to say is we're going to use a while loop. We're going to say while pstr is not equal to this null terminating character. Right. What we want to do is we want to print out what's in the string character by character. So still printf. To print out characters, remember we use the %c. Right, and I'm going to now use the indirection operator with ptsr. And now we're just going to increment ptsr by 1, so it'll point to the next character. And let me check my syntax here. All right, let's try run the cursor. All right. So here we've got our string that we had before with ELAC. It's null terminated. Notice that pointer to string, right, points to then this string. The watch window here in the debugger is actually showing us the first few characters of the string it points to in this case. But we're saying while ptsr is not equal to 0. Well, let's see, its address here is, we'll take note of 28ff02. Right. So I'm going to say next line. All right, next line we print out, we can pop up this up, we can see we printed out the first character. Now, when we add 1 to this, remember it's adding 1 times the size of a char, which is 1 byte. So it should point to the next byte in memory. So notice now we went from 02 to 03. Right. And we're going to print that out. All right, there's our next character. And then we say next line, well, we add 1 to pointer, it points to the address 04. Right. In this case, it's still not pointing to the null terminator, so we print out then the second E here. Right? We're going to add 1 to this, it'll point to 05. That'll point to the C. So we can see then that printed out. Now, when we add 1 to this, that means when it comes up here, now then, actually, I have a typo here, which you all have probably spotted, because look, I would expect to print to the point to the null terminator when I say next line. Notice that was true. What did I forget to do here? In my haste, I forgot to use the indirection operator. I need to use the indirection operator to compare to the actual character. I need to read what that's pointing to point to the actual character. And if I hadn't been so cavalier as to ignore probably any warnings that came up, we'd have seen that. So let's go ahead and save that. Actually, let's clean out our workspace. Let me go back to the way this is, and let's just compile. And now that did not give me a warning, which I'm not very happy about. So let's put this up, recompile. Right, this is correct. Let's build this. And now let's run through this again. All right, so we're going to, as we run through this, first it points then to 02, which is the E. It then points to the L, 03, 04. It points to the C right here. Right, so as we do this, it's now going to point to the C. We'll step through this. Now when we add 1 to this, this should point to the null terminator. So now when we use the indirection operator with this, we should see this test will be false because it will be equal to the null terminator, and now it drops down here. Right? And so we printed that out. Yes, we need the indirection operator to read what's stored in the area where this points to. Right? And so this is just a way then of looping through here line by line, accessing what's in the character array. It's important to know how to do this because sometimes you need to search a string for pieces of information. So knowing then how to use pointers to iterate through the array to search for that information is important. Right. Now this was the more tedious way of printing this out, right? Because when we run this, we still get the message ELEC. If our only objective was to print out the entire string, we simply could have used %s with a printf to print that out. But we wanted to see how to use an array in this example to step through this and keep stepping through until we find that first null terminated character. That was the point of this example. Now let's take a look at one other thing here. All right. So here we saw before that if we use printf with a %s, right, and said go ahead and print out what's in string, that we'll get that information out, right? No new line character, we just get that. All right. Remember then the function puts, right? The prototype for the function puts is int puts const char star s. That's the function prototype. Put stands for put string. And we've seen before that we could call puts and write something like anything we type inside double quotes here is going to show up. So if I turn off this printf, right, if we just go ahead and build and run this, sorry, I should have my email turned off here. All right, we get the message hello out here. Yeah, we really don't care about Bagel Monday, do we? I need to unsubscribe from many of those things. All right, so here we've used puts in the past to just display a string. We know puts automatically adds a new line character to that, right? Well, since puts takes an argument that's a constant char star, remember then the string literal is a constant char star. I could simply, now we could use puts with the name of our array, right, where our string is stored, build and run that, and we get out ELEC, and then with a new line character appended. So both of these, if I add the new line character here, are equivalent. Now we'll see it coming out twice. Right, same thing. Right. So puts can be a convenient way then for you to simply just pass the name of the array to that to display your message that's in there. So both of these are essentially equivalent. All right. Let's write a new example here, right? So we're going to, let me get rid of this here. Okay, we're going to write a program that's going to read a string. So read a string from the keyboard, right, which is standard input. And then let's see, what should we do? Let's count. So let's read a string from the keyboard standard input and store it in a character array. And then let's count the number of uppercase letters and count the number of lowercase letters. Okay. So let's then create some sort of array that has memory for our message. So its data type is char. I'll call it MSG. In this case, let's just make it 100, right? And now, let's see, we're going to have to maintain a count. So let's have uppercase count, right? Initialize that to 0. Lowercase count, we'll initialize that to 0, declare and initialize. And then so we're going to read the string using gets. Right, let's use our new function. So gets, all we need to pass to gets is the name of our array. So remember, gets is going to skip over any leading white space. It will include white space in between the words. Remember, once it skips over the leading white space, as soon as it finds a non-white space character, it will start reading, and it will keep reading until it encounters the new line character or end of file function. All right, we're going to type less than 100 characters to make sure that everything fits in our array. And let's just as a quick check, let's just use puts to write back out whatever we stored message. All right, just as a quick check. So let's build. All right, it's complaining about some unused variables because we're not doing the count yet, but build and run. All right, now I don't have anything telling me what to do, but I'm going to type the sentence is long. All right, hit the enter key, and it prints that information back out. All right, so before I use gets, let's maybe then use write a message that says enough enter the string. Right. That's a little more user friendly. And once again, if we build and run, enter the string, and notice then I can type numeric characters in here. So word 1, actually word 1, word 2 is part of that, right? Word 3 is separate, and the end. And so it then read all of this in, right? I didn't have any leading white space, but it read all of that in. The enter key press was my last thing that I stored in here. Right. So we can successfully use gets to then read and store something in a string. Remember, gets will read in multiple words. If we were using scanf, we'd only get that one word read in, right? If we were to just go ahead and let's review then how scanf is different. If I said scanf, right, %s here, and said MSG, all right, and I type something like word 1, space word 2, word space 3, the end, enter key press. Remember, scanf with %s only reads in, scanf skips over any leading white space. As soon as it encounters a non-white space character, it starts reading. And then when it encounters this white space character here at the end of word, it stops. All right, so all it's going to store in message is this first word, W-O-R-D. All right, whereas we can see now if we turn gets back on, remember gets skips over leading white space. It will read in white space in between words. Remember, gets is going to keep reading. Word 1, word 2, word 3, the end, enter. So gets reads until we get that enter key press. Right? So remember, gets, think of gets as reading in multiple words. It can skip over the white space in between. It will just keep reading until it gets that enter key press. Scanf will stop reading once it encounters a white space character, including the enter key press. Right. That's a quick review of the differences between those. What we want to do is after we've entered our string now, let's go ahead and then we want to count, right? So count the upper and lower case letters. All right, I just want to find out how many are uppercase, how many are lowercase. And we're going to use a loop to step through that. Now there's different ways we could do this, right? Our first way is we're going to need something, we're going to use a pointer. So we're going to have to declare, we're going to use a while loop. So let's declare now a pointer to this. So let's then go up here and create this pointer, char, I'm going to call it start P message or PTR MSG for pointer to message. And then down here, let's go ahead. At some point after we've read in, well, at some point we need to make the pointer to the message point to that. So let's assign a PTR message the address of message. And now I can say while, use the indirection operator, PTR message, right, is not equal to, remember this is always terminated with a null terminator. Well, that's not equal to that. In here, we want to perform our character count. So in here now, right, if I want to distinguish if something's an uppercase letter, I can say if, use the indirection operator, so dereference that. If the character or PTR message is then greater than or equal to a capital A and PTR MSG is less than or equal to a capital Z character, well then let's add 1, so plus plus uppercase count. Let's add 1 to that. Else if, right, dereference PTR MSG is greater than or equal to a small a, and using the indirection operator there, right, with the pointer is less than or equal to a lowercase z, right, let's add 1 to our lowercase count. Right, and that's what we're counting is upper and lowercase number. Now we want to iterate through the array, so we've checked this. What we need to do is we need to make sure that we make pointer message point to the next character, right? We always look for the null terminator. Whenever we work with a string, we look for the null terminator as our end condition. When we get down here, we should be able to print out, let's see, uppercase count, right, %d. Maybe we'll just do the lowercase count, the same line. Uppercase count. I'm going to wrap this around so you can see it. Lowercase count. All right. Maybe I want a couple of new lines before I show that. All right, let's build. All right, no compile errors. All right. So let's just go ahead and do something fairly simple. Let's run it. And let's just run it with capital H-E-L-L-O. We should have 4 lowercase letters and 1 uppercase. So uppercase is 1, lowercase is 4. Right. Let's do a run to cursor here with H-E-L-L-O, W-O-R-L, little d. Now I've got 1, 2, 3, 4, 5 uppercase, 1, 2, 3, 4, 5 lowercase, maybe 3 more at the end, so 6 more lowercase. And then it shouldn't count spaces, right? If we put numbers or other characters in there, that shouldn't affect the count. And hit the enter key. All right, so it read this in. All right, so now here in the debugger, it read this in. We can see then MSG has everything in here, hello world, the end, the 3, the spaces, the 8, the 4. Pointer message is pointing to the start of this array. And so we're going to say, while this is not equal to that terminating, the null terminator there, right? So the first character, capital H, should be true, right? If this should be true, we should add 1 to uppercase count. We do. Then we're going to add 1 to pointer message, right? So this then points to the next character, right? Byte, the next byte where the next character is stored, right? Which should be the E, right? This will be false. This will be true, lowercase e. We add 1 here. Then pointer message points to the next byte of memory, right, which will be the lowercase l. This is true. We add 1 to the count. We make it point to the next one. You can see the pointer message count, the address going up. All right, this will point to the second L. So we're going to add 1 to our lowercase count here. All right, we go to point at the next address. Now this will be the lowercase o. So we'll add 1 in there. All right, this next one will be the space. So this won't be true. This will not be true. So we'll go ahead and point to the capital W next. This will be true. We'll add 1 to that. Point to the next one. Point to the capital O. This will be true. point to the next character, which will be the capital R. This will be true. We'll add 1 to that. Point to the next character, which is a capital L. So we'll add 1 to this uppercase count. Point next to the small case d. This is not true, but small case d, this will be true. All right, now we're going to point to the space in between world and the n, and neither one of these will be true, so we'll increment the pointer. Right, you get the idea of what this is doing, right? As it walks through and finds these other lowercase letters, it just keeps adding into the count, right, until we walk all the way through the message. So if I set a run to cursor there, so that finishes, all right, next line, right, gives us then the count for that message. Right. So that gave us a way then to search the array. Remember, whenever we're going to search one of these character arrays, one of these strings, we always search until the null terminator. The reason being is we made this large enough to hold 100 elements, but we don't know how many characters the user types in. Right? But we do know that a null terminator will always be stored at the end of the message. So we keep going until we find that null terminator, right? That gives us the length of our string. It lets us know when to stop. All right, so you can experiment with this as well, entering some different characters. All right. So let's take a look at how we would write a function to calculate the length of a string. Right. So we're going to read a string from the keyboard standard input and store it in the character array. And I'm going to count the number of characters stored in the array, right? The number of characters stored is known as, let me get for this, is known as, we call it the string length. All right, so when we want to know the string length, that means we want to know how many characters are stored in that array. We're going to keep reading until we find the null terminator. All right, so let's just then create a variable called string length. We'll have the user enter the string. We're going to use a pointer to point to it. This is not going to change, but all we're going to do here is every time we encounter a character, so we're going to include everything stored in that string, white space, any sort of character. We just want to know how long. Every time we walk through here, we can just add one to string length. And then we'll increment our pointer as well. And so here we'll change what we're printing out. Right. String length. And my variable is different. String length. So let's just build and run. Let's start with our usual simple hello, 5 characters, string length 5. Okay. Let's go ahead and do a run to cursor and let's do hello world. So HELLO space WORLD, enter key. All right, so now we're in here, we've got hello world, here's our null terminator immediately after the D. So hello we know is 5 characters, the space was 6, 7, 8, 9, 10, 11, right? Because another 5 for the word world. So we should end up with a string length of 11. Let's walk through it. Right, next line, this won't be equal to null terminator. We're going to add 1 to string length. We're going to point to the next character. All right, so now you can see we're pointing to the E. Right, we add 1 here. We point to the next. We're pointing to the L. We add 1. We point to the second L. All right, now we're going to point to the O. Now we're pointing to the space. Now we're pointing to the W. Right, and then the O, and then the R, the L, and the D. And finally, when we point to that null terminator, this test is false, we can see string length has 11. Right? So we can then write a very simple loop we need to maintain the count. We need to initialize this count to 0, right? And we just simply walk through this array until we reach the null terminated character, counting the number of characters stored in there to give us the string length. All right, that's the end of the section of video examples. What we're going to do in the next video is we're going to look at some special functions in the string library that are written to do things like this, like to calculate string length, string concatenation.